Hi guys, welcome to a mini research video, and the lesson topic is right triangle trigonometric ratios. The aim is how can we apply the trigonometric ratios to make use of structure and precisely complete related order. How can we should be here, and the learning objective is to complete mini research to extract and apply to real-world problems the theorem governing trig ratios as it relates to right triangles. The lesson resources are there. This is the activity sheet. You have your Regents Review packet that I gave you. And if you look at page A6, you'll see some information. This video research, your Barron's course book, page 207 to 213. And you will definitely need a calculator for this video. So for those of you who have one, you are definitely ahead of the game. Awesome. So now we are going to be looking at vocabulary development, and we're going to look at the parts of a right triangle as it relates to an angle. Now this angle right here is called theta, and that's how it is. It's just simply an O when you put something like that through it if you don't know. Now when it comes down to theta, we're going to talk about the different parts in relationship to theta. Now, in regards to the hypotenuse remains the same. So let's get rid of this right here. And then our hypotenuse is always the side that faces the right angle. And remember, hypotenuse is only found in a right triangle. All right, so we have the hypotenuse now, but then we have this angle here, and wherever the angle is, the side that it faces is called opposite, meaning opposite to the angle. So this is the opposite. And then next to the angle, we have the adjacent. So we have the hypotenuse opposite the angle that is in question is called opposite, and then right next to it, and it's always in reference to a given angle or the angle that you are working with. All right, so let's look at this one, and I'm going to give you a few times. This is the angle, right? Of course, we know opposite the right angle, we call it the hypotenuse. It's the longest side in a right triangle. But what is opposite now? Now the opposite would be here in regards to the angle, and then we have our adjacent right here. Now the words we're going to use is we're going to use O for opposite, A for adjacent, H for hypotenuse. So let's do a quick review. So if we talk about an angle, we're going to make this angle the star of the show. Now this is the star, and then opposite the star is the opposite, and then we have next to the star is the adjacent. But then the hypotenuse is always across from the right angle. Alright, now let's go to this guy. Now the star moves here. The star opposite that, we have the opposite. Next to the star we have the adjacent. And then of course the hypotenuse is always opposite the right angle. Alright, so let's just do a quick recap. So we have our main angle, theta. Opposite the angle is opposite. Then we have adjacent next to it. And then H is always the hypotenuse. Again, now we have theta somewhere else. We have the opposite across from it. We have adjacent next to it. And then we have the hypotenuse, which is always the longest side of a right triangle, and it's opposite the right angle. Now let's just do some definition. The hypotenuse is the longest side of a right triangle, only for a right triangle, and it's always across from the right angle. Then the opposite, the side across from the angle, and the angle is called theta. And then adjacent is the side next to P angle. And of course that's theta. Alright, now theta is pronounced theta, and it's the symbol for an angle. For an angle in a triangle. Alright? Now in trig ratios, there are going to be three important trigonometric terms that we need to know. We need to know sine, cosine, and tangent. And you are going to be introduced to it now, but later on you'll definitely get into it when you get into Algebra 2 trig. Now, in terms of sine of theta, and it's also on the calculator. If you look on your TI-84, it's there. The sine of theta is the ratio. And once we hear the word ratio, we have fraction or relationship of the opposite side divided by the hypotenuse. Right? And then I'm going to talk about that later on. So that is actually, it's the opposite divided by the hypotenuse. And that's what it looks like. Then we have the cosine is the ratio of the adjacent side divided by the hypotenuse. So we have A over H. And then we have a tangent is the ratio of the opposite side divided by the adjacent. So we end up with O over A. And then we're going to find out what a simple acronym is to remember all of this. So here's a simple acronym to remember all of this. SOHCAHTOA, right? So is sine theta is equal to opposite over hypotenuse. Then we have CA. So we have CA, and that is cosine, we use cos theta is equal to adjacent over hypotenuse. And then for our last guy, we are going to, it's TOA, and that is tangent theta is equal to opposite over adjacent. It sounds like a song, SOHCAHTOA. So it sounds like some kind of calypso song, right? For my Caribbean people, you can relate to this. Soca and the Toa. Alright, so Soca, Miss Roa, no, it's SOHCAHTOA. Now, if you use your calculator, you can always find out what the equivalents of certain particular angles are. So if you take out your calculator and you look, make sure it's in degree mode, and then just type in sine. Sine is there on your calculator. Look, sine and press 30, and the answer would be 1 over 2. If you put sine 60 in your calculator, the answer would be 1 over 2. And if you put tangent of 45, the answer is 1. So now let's use SOHCAHTOA. SOHCAHTOA to find out what if we had sine 30. Now remember, we are doing everything in terms of the angle. Now this would be theta, and theta has a value of 30. So remember, sine is opposite over hypotenuse. What's opposite? Opposite to the angle is 1, and then the hypotenuse is this guy is 2. If you do cosine 60, now cosine is adjacent over hypotenuse. In this angle, this is our theta, adjacent is 1, and then hypotenuse is still 2, right? Then let's look at now if you look at tangent of 45 and tangent So we have to know what angle it is and also what trigonometric ratio we're using. So tangent is opposite over adjacent. Now opposite is 3 and adjacent is also 3, and that is equal to 1. Alright, so that is what tangent of 45 is, cosine of 60 is, and sine of 30. Alright, so there is a little bit of something that you need to be aware of. Alright, so let's look at some model examples to help us figure out which trigonometric ratios to use. We're going to label our sides opposite, adjacent, or hypotenuse, and everything is in regards to angle. All right, so this angle in question, let's look at this one, right? Let's look at this one. So the angle in question is 20, right? So we have 20 right here, and then so we're going to look at the opposite. So what is opposite to 20? X, right? So this is our opposite, right? And then of course we know our adjacent is right here, which is not opposite, so that's our adjacent, right? So we know that is O, and then that's not adjacent. I'm so sorry. Take that back. That is horrible. That is the hypotenuse. Now because we have opposite and hypotenuse, the only ratio we could use opposite and hypotenuse is so, and it's sine. Now in this case our angle is 20. So sine of 20 is equal to x over 8. What can we do? We'll be able to find out what x is. Alright, so after we find out what x is, we could go ahead and work it out in using our calculator. Alright, so we're solving for x. Now to get rid of that, we have to, let's write over again, 20 x over 8. We have to multiply both sides by 8. So that side by 8 and this side by 8. And what happens when we do that is we're going to end up with, using your calculator, 8 sine 20. So we're going to have 8 sine 20 is equal to x. And then when we evaluate that, x will be equal to 2.74 rounding to the nearest tenth. And that has to be stated. Normally we round to the nearest thousandth, but we're running to the nearest tenth. So make sure you have your calculators handy. Alright, so let's look at the second one now. This is 1, 2, and number 3. Let's look at number 2. Remember they said that we need to label the sides opposite, adjacent, or hypotenuse. In regards to the angle, we don't have an opposite, right? So this is opposite, this is adjacent, and this is hypotenuse. Now all we have is the adjacent and we have the hypotenuse. So which one works with adjacent and hypotenuse? It's cosine. So in this case we have to use the cosine of 55 is equal to adjacent is 7 and hypotenuse is x. Now right here we have to multiply both sides by x to get the x as from a denominator. And then we're going to work over this side. So we have x cosine 55 is equal to 7. Now we divide. We're going to divide by cosine of 55. Do not calculate this cosine 55 yet until you we're not doing this question until we finish out. So when we cancel out, this cancels out. So x is equal to 12.2. Alright, 12.2. Alright, so that is what x is, the length of x. Now we are working on finding the missing side, and that's what you do to find the missing side. It has to be a missing side. Now again, we're going to look at number 3. This is our angle. This is our opposite. This is our adjacent. This is hypotenuse. Now what's given? We have an angle, and then we have opposite, and then we have adjacent. So O and A will go with tangent, right? So it's tangent of 38 is equal to opposite is x over 4. Now what do? We're going to multiply each side by 4, so we could get rid of it as a denominator. So what do we end up with? We end up with 4 tangent 38 equals x, because this cancels out. What is 4 tangent 38 in your calculator? You're going to end up with x is equal to 3.13, and that is your final answer. And that's what you do to find the missing side. Now, we can also use this to find a missing angle. Alright, so now we are solving for a missing angle right here. In order to solve for the angle, we have to use the inverse function on our calculator. You need to hit the second button before the trig ratio you want to use. So of course we're going to go ahead and label opposite, adjacent, and hypotenuse. Now this is our angle, and our angle is missing. We're going to actually use these two sides to find what the measurement of our angle is, and that is possible. This is only for a right triangle. Now, our opposite would be 3. This is our hypotenuse, and we don't know what adjacent is. And we don't care, because what do we have? We have opposite and we have hypotenuse. And in terms of SOHCAHTOA, which one goes with opposite and hypotenuse sign? So we're going to find a sine x is equal to opposite 3 over 7. Now we want to find out what x is, and x could be also called theta, but it's missing, so we call it x. Now we're going to find the inverse of both sides. So if you're showing your work, this would be the best way to show your work. To undo, right, we're going to is equal to we're going to find a sine inverse of 3 over 7, and this cancels out this. Alright, so we end up with x will be equal to 25.4. You're going to use that in your calculator. Alright, let's continue with another problem. So we did the first one, second one we're going on to. So now we have a sine. This is opposite, this is adjacent, this is hypotenuse. Now x, we don't have the opposite, so we can't use that, but we have adjacent and hypotenuse, and the one that goes with that is cosine. So we're looking for the cosine of x is equal to adjacent 2 over 5. So of course we're going to take the inverse of both sides. Bring this over us a little bit more, because we don't want to, you always put the sine first, the cosine inverse, right? So it's cosine inverse, and this goes in parentheses as it should in your calculator. So this cancels out this, and then we're left with x. X is equal to cosine, inverse cosine of 2 over 5 is 66.4 degrees, and that's the measurement of the angle. So let's look at number 3. Of course, we have our opposite, we have our adjacent, and we have our hypotenuse. We don't have the hypotenuse. What's given? We're given the adjacent and we're given the opposite. And for opposite and adjacent, only trigonometric ratio that goes with it is tangent. So tangent of x is equal to opposite 6 over 8. So now let us do our work that we normally do. Tan x is equal to put 6 over 8 over this side, and we're going to take the inverse of that, tangent, and then you're going to end up with these two guys being cancelled out, and x is left. X is the tangent of x is equal to tangent, inverse tangent of 6 over 8, and that happens to be 36 0.9 degrees. So that is it. Now, based on what we've done, I want you to elaborate on why this theorem is applicable to this problem. So for tomorrow, I want you to have all of these notes done, and I want you to answer this DOK question, and you're going to work on the U try, and you're going to let me know if you were able to come up with the answer, and we will look at it tomorrow. Make sure all of this is done before you come to class, so that I won't be spending the time to go through the content, because you guys will already have done this. So all we're going to do is address the practice problems in class. So have a good night, and I hope you have your note sheets ready and for class tomorrow.